Our universe is vast. It's also old, really old. About 13.8 billion years old, to be precise. That's a number so big it's hard to wrap your head around. Imagine all the grains of sand on all the beaches on Earth. Now multiply that by 1 billion. That's a lot of sand, and still not even close to the age of the universe. In all that time, the universe has been busy. It's been expanding, cooling, and creating. One of the most amazing things the universe has created is planets. Planets are giant balls of rock, gas, or ice that orbit stars. Our own Earth is a planet, and it's pretty special to us, but it's just one of billions of planets in our galaxy, the Milky Way. And the Milky Way is just one of billions of galaxies in the universe. That means there are a lot of planets out there. Some of them are probably a lot like Earth. Some of them are probably very different. And some of them are probably very, very old. These ancient planets hold clues to the early universe, a time when everything was very different from what it is today. By studying these ancient planets, we can learn about the conditions under which planets formed, the types of stars that hosted them, and the early evolution of our universe. It's a journey back in time, a cosmic archaeological dig that helps us understand where we came from and what else might be out there. To understand how planets form, we need to go back to the very beginning, to the event that started it all, the Big Bang. About 13.8 billion years ago, the universe as we know it was compressed into an incredibly hot, dense point. Then, in an instant, it exploded. This wasn't your everyday explosion, like a firecracker going off. This was an expansion of space itself, flinging energy and matter in all directions. As the universe expanded, it cooled. Energy converted into particles, forming the first matter. Over millions of years, this matter, mostly hydrogen and helium, the simplest elements, started to clump together under the influence of gravity. These clumps grew bigger and bigger, eventually becoming so massive and dense that their cores ignited in nuclear fusion, the process where atoms fused together, releasing enormous amounts of energy. The first stars were born. These early stars were very different from our sun. They were much bigger, hotter, and shorter lived. But they played a crucial role in creating the ingredients for planets. Stars are like giant cosmic kitchens. Inside their cores, they cook up heavier elements from lighter ones through nuclear fusion. These heavier elements, like carbon, oxygen, and iron, are essential for building planets and eventually life itself. When these massive stars eventually died, they exploded as supernovae, scattering these newly formed elements across the universe. These enriched clouds of gas and dust, remnants of dead stars, became the nurseries for new generations of stars and planets. Gravity pulled the material together, causing it to spin and flatten into a disk. In the center of the disk, a new star ignited, our very own sun. Around the young sun swirled a disk of leftover material, gas, dust, and icy grains. This is where planets came in. Tiny particles in the disk collided and stuck together, a process called accretion. Over millions of years, these growing clumps attracted more and more material, eventually becoming planetesimals, the building blocks of planets. These planetesimals continued to collide and merge, eventually forming the planets we see today. Now let's dive into the enthralling story of the oldest planets in our universe. These ancient celestial bodies have witnessed the birth and evolution of countless stars and galaxies. You see, they hold secrets that could unlock the mysteries of our own origins. It's fascinating, isn't it? So join me as we explore how these primordial worlds came to be and what they can tell us about the cosmos. Ready? Let's embark on this cosmic journey together. Ancient planets, those that have been around for billions of years, hold the keys to understanding the early universe. They tell us in their quiet, enduring way about the conditions that prevailed just after the Big Bang. Studying them helps us piece together the cosmic puzzle of how galaxies, stars, and planets formed and evolved over time. Despite our advancements, there are still so many unanswered questions. How exactly did the first planets form? What materials were essential in their creation? Ongoing research aims to delve deeper into these mysteries, utilizing ever more sophisticated tools and methods. Every discovery, no matter how small, brings us a step closer to understanding the full story of our universe. With the advent of new technologies, our ability to explore the cosmos has expanded dramatically. Telescopes with unprecedented power, space probes traveling farther than ever before, and advanced computer simulations are revolutionizing our understanding. These technologies are not just tools, they are windows into the vast, uncharted territories of space, revealing new discoveries that continuously reshape our knowledge. The universe in all its vastness is a place of endless wonder. Each new finding, each answered question, opens up a myriad of new mysteries to explore. It reminds us of the boundless curiosity that drives human exploration, and the infinite possibilities that lie ahead. As we continue to look to the stars, we're reminded that the journey of discovery is never-ending, and the universe will always have more secrets to reveal.